Okay, so what we see here is, in this lesson, we're going to learn about the natural logarithm. So remember that e was the natural number. So you can see that equation right here. And we talked about in class how logarithms and exponential functions are inverses. So here you see the inverse of e, which would be the natural log because it has a base of e. Now just notice we don't write it like this. Instead, we write it like this. No new ideas here, just understanding using e as the base of the log. So here, to rewrite each expression as a single logarithm, this reviews some of our properties. Each of these multipliers out in front of the logs becomes an exponent. Now these two logs have the same base because they're both natural logs, so I can combine them into one, in which the 2 to the third would be divided by the x to the third. So my final answer would be the natural log of 8 over x to the third. Here, same idea, so I'm going to have the natural log of 3 squared plus the natural log of 8. These two are being added, so they're going to become one logarithm where these two quantities are being multiplied. 3 squared is like having 9, and 9 times 8 is 72. So here my final answer would be the natural log of 72. Then in part C, we see it's a little more complicated. So we're going to have the natural log of x to the 20th plus the natural log of y to the 5th minus the natural log of z squared. Now, one comment about this. I'll make my z's like this so we can tell them apart. This is going to be three things combined into one logarithm. Now, the addition here tells me that these multiply. The subtraction here tells me this divides. That means the z squared is going to end up in the denominator. And the x to the 20th and the y to the 5th would both be multiplying each other in the numerator. So again, review of log properties just with a natural number base. So same thing here, solving the equations. Remember, when we're solving log equations, we want to rewrite them in exponential form if we're stuck. So here would be e to the 5th equals x. Now again, the reason that would be e to the 5th, remember that natural log really means log base e of x equals 5. So this is our base, it's our exponent, and x goes on the other side. And then we could just use our calculator to evaluate e to the 5th, and that will give us a result for this problem. So e to the 5th power is 148.4. For the second one, again, the same idea. Okay, you can think of this. We don't really write this. I'm just writing this right now to get your mind thinking the right idea. So this is a log function that doesn't seem solvable right now, so I rewrite it in exponential form. Okay. I'm going to subtract 1 from both sides and then divide by 6 to get x alone. So if you were taking like a non-calculator test, you could leave the expression just like this, e to the 3rd minus 1 over 6. But with a calculator, you could evaluate e to the 3rd, subtract 1, and divide that by 6 to get that x is equal to 3.18. So then finally, we have a similar problem. So again, I'm going to rewrite this, e to the 6th equals 2x plus 1 squared. Okay. Or we could have made this problem a little bit different. Let's see if this helps us. I'm going to bring the 2 to the front, so I'm going to rewrite it like this. I'm thinking if there's a way I can do this without having the squared term. So if I rewrote it like this and then divided both sides by 2 first, that would make my life a little bit easier. So what this is going to do is make it that I don't have to deal with that squared. So it's going to be e to the 3rd equals 2x plus 1. And so then I'm just going to subtract 1 from both sides and then divide by 2. So again, you would leave that expression like that without a calculator, but with a calculator, you would calculate e to the 3rd, subtract 1, and divide that whole thing by 2, leaving you with 9.54. Same way we solved log equations before, this time just using that base of e. All right, so finally, exponential equations with e. We talked about if you can't make similar bases, which here I don't know the powers of e by heart, so I'm not going to be able to rewrite 24 with the power of e. We talked about taking the log of both sides. Now, in this case, because they're using e, I'm going to actually use the natural log, and I'll show you why. This is going to work out a little bit nicer. You don't have to do it this way. You could do it the same way you did before, using the log of both sides, but just to show you some of these other properties. Now, I can use the natural log because it still has a button on my calculator. Now, calculating this right here, remember what this is asking you. The base of the log is e, so it's saying e to what power is e to the x plus 3 power. So clearly, it's just going to be x plus 3. That's what's nice about using a log with the same base here. Same base, you just end up with this exponent. Think about it, and I'll erase this in a minute. But if you had log base 3 of 3 to the 8th power, this is saying 3 to what power equals 3 to the 8th power? The answer would be 8. So whenever the base of the log matches the base of this power that you're trying to make the log of, the exponent you see showing up as your answer. So that's why in these problems, where e is the base of the function, it's nice to use the natural log when solving because it makes the solving a little bit simpler. So now I can see that my answer without a calculator would be the natural log of 24 minus 3, or I can type that into a calculator. So the natural log of 24 minus 3, this gives me 0.178. So if I do the same thing with the next problem, the first thing I would do is divide both sides by 5. And then, again, I would take the natural log. And remember, my purpose in trying to use the natural log, sorry about this, is that the natural log, again here, e to what power equals e to the negative 3x power. We're just going to get the power. So this makes it a lot easier for me to solve. So I would either leave the answer as log of negative, or I could put it into a calculator to get that the answer is negative 0.732. All right, so again, go through the same process here, isolate that e, and then use the natural log on both sides. So I'm going to first add 8 to both sides, and then I'm going to divide by 2, and then I'm going to take the natural log of both sides. So again, right here, taking the natural log of something that has e to a power is just going to end up being that power, and then I'm going to divide both sides by 5. So again, not a calculator, my answer would be log of 19 divided by 5. With a calculator, my answer is 0.589. Okay. So basically, the natural logarithm just uses the natural number as a base. And this lesson reviews our properties of logs and how to solve log and exponential equations, but adds a little twist on it with using the number e. So go ahead and complete the homework that goes with this, and we will talk about it the next day in class.